You'll be delighted to know that the rules for multiplying integers are much simpler than the rules for adding and subtracting integers. Let's look at a pattern to establish the rules. Now notice that here I have 4 times 5 is 20, 4 times 4 is 16, 4 times 3 12, 4 times 2 8. What I want you to notice is that the 4 is staying the same for all of these, and I'm reducing this second factor by 1 each time. So 5, 4, 3, 2, 1, 0, and on into the negative values. Now I want you to notice what's happening to the product. We start with 20, then 16, 12, 8, 4 as the product of these two factors. And 4 times 0 is 0. Now looking at the pattern, what would you expect for the answer to 4 times negative 1? Well, let's see, 20, 16, 12, 8, 4, 0. Oh, gee, it looks like we're approaching 0 here. Numbers are getting smaller and smaller. They would therefore go into the negative values. We would get negative 4 here if we're reducing by 4 every time. And reduce negative 4 by 4 to get negative 8, and reduce this by 4 to get negative 12. So 4 times negative 1 is negative 4, 4 times negative 2, negative 8, and 4 times negative 3, negative 12. This seems to establish the idea that if we're multiplying a positive number times a negative number, we get a negative result, and that is the case. Now another way to see that positive times negative is going to be negative is like this. That we said earlier when we talked about multiplying whole numbers that multiplication can be thought of as repeated addition. That is, we can think of 4 times 2 as adding 2 4 times. That is, 2 plus 2 plus 2 plus 2 is 8. You see, so we have we're using 2 as an addend 4 times, using that same idea down here. 4 times negative 1 means use negative 1 as an addend 4 times. So negative 1 with negative 1 with negative 1 with negative 1 would give us negative 4, and we could apply the same idea to the others. All right, now, so we're establishing the idea that a positive number times a negative number gives a negative result. Now, we know from our rules for multiplication that we have a commutative property for multiplication, and it holds here with the integers as well. And that means that we can swap sides here. We can change the order of the numbers being multiplied. Rather than 4 times negative 3 being negative 12, we could say that this is negative 3 times 4 is negative 12. And let's start with that idea up here with the next pattern. So negative 3 times 4 is negative 12. And positive times negative is negative, so negative 3 times 3 would be negative 9. Negative 3 times 2 would be negative 6. Negative 3 times 1 would be negative 3, and negative 3 times 0 is 0. All right, now again, we have a pattern here where the negative 3 is staying the same. We are reducing the second factor by 1 in each of the products, or for each of the multiplications. And notice what's happening to the products. We have negative 12, negative 9, negative 6, negative 3, 0. If we were looking at these numbers on a number line, the numbers are becoming larger. They're going to the right on the number line. So if we continue the pattern that we see here, notice that they're increasing by 3 every time. Add 3 to this, we get that. Add 3 to this, we get that. Add 3 to this, we get that. Add 3 to this, and we get 3. Add 3 again to get 6. Add 3 again to get 9. So negative 3 times negative 1 is 3. Negative 3 times negative 2, 6. Negative 3 times negative 3, 9. What we're establishing here is the idea that when we multiply two negative numbers, we get a positive result. Negative times negative is positive. Now here's how we'll remember the rules that we've established here. We're going to remember it like this. When we have the same sign, either both positive or both negative, we get a positive answer. That's all there is to it. When the signs are different, we get negative answers. And that's it. We don't have to worry about whether the positive number is with the larger digits and all of that kind of thing that we did before. So it's much, much simpler. It's just the idea that if the signs are alike in the numbers being multiplied, then we get a positive answer. If the signs are unalike, then we get a negative answer. So we can work problems like these. 4 times negative 7. Unlike signs, negative answer. 4 times 7 is 28. Negative 5 times 2. Unlike signs, negative answer. 5 times 2, 10. Same signs, you see they're both negative, so we get a positive result. I'm going to put the plus sign here just for emphasis. We usually wouldn't write it. 15 times 2 is 30, so positive 30, or just 30 would be our answer. Up here, negative 3 times 5, unlike signs, negative answer, 15. Negative times negative, same sign, like sign, positive result, 1 times 12, 12. 5 times 4, this is kind of trivial, isn't it? This is what we've had in the past. So it's positive 5 times positive 4, like sign, positive answer, 5 times 4, 20, as we would expect. When we have a string of integers to be multiplied, we just want to go from left to right and pick off 2 at a time. So we would just multiply like this, and it's really easy. 2 times negative 3, unlike sign, negative answer, so we have 6. Or excuse me, negative 6, and we bring down the other items to be multiplied. And then just do these. So like sign, positive answer, 6 times 5, 30. And then 30 times negative 7, unlike signs, negative answer, 7 times 30, 210. So negative 210 for the result. I don't recommend that we try to do this any faster than we're doing it right here. It's a good organizational process to just do 2 items at a time and then bring down the items that we haven't worked on. All right, on this one, the same idea. From left to right, negative times negative, positive. 5 times 4, 20. And then bring down the other factors. And then 20 times 6. Let's see, that would be 120. And bring down the negative 3. 120 times negative 3, positive times negative, negative. 3 times 1, 20, 3 times 0, 0, 3 times 2, 6, 3 times 1, 3, so negative 360. When dividing integers, follow exactly the same rules that we follow for multiplying. That is, when the numbers involved have the same sign, we get a positive answer. When the numbers involved have different signs, we get negative answers. So we can work problems like this very quickly. 8 divided by negative 2. You see, we're thinking 8 over 2. 8 divided by 2 is 4. But just think of the sign pattern to establish the sign of the answer. Positive divided by negative. Signs are different, so we get a negative answer, and it's negative 4. Now here, again, the signs are different. Negative 8 over positive 2, so we get a negative result. 8 over 2, 8 divided by 2 is 4. And then negative 8 over negative 2, the signs are the same here, so we get a positive result. 8 divided by 2 is 4. And here is the trivial situation. The signs are the same. They're both positive. 8 divided by 2 is just 4. Negative 15 divided by 3. Negative divided by positive. Different signs, negative answer. 15 divided by 3 would be 5, so we have negative 5 for the result. 21 divided by negative 7. Unlike signs, negative answer. 21 divided by 7 is 3. I think it's kind of important in problems like this you can kind of separate your thinking between writing the sign of the answer and writing the digit part of the answer. You see, and I think that's a good way to keep things organized. Just go through one of those at a time when you're establishing the answer. So here you would look at the signs, write down the sign of the answer. Then look at the digits and write down the digit for the answer. And in this one, same sign, positive answer. You can write nothing or write a plus sign if you want to. But the answer is positive. You establish that first. 32 divided by 8 would be 4. So the answer is 4. The request for division can be made in a lot of different ways. Here it's made by using the division symbol, but the rules are exactly the same. The signs are the same, so we get a positive result. I would write nothing over here probably, and then I would think, well, 8 into 120, or 120 divided by 8 means the same thing, is 15. So the answer is 15. In this one, once again, I'm looking at the signs as the first order of business. I have unlike signs. I'm going to get a negative result. And then I think about what I get for 95 divided by 5. Oh, that's 19. So negative 19 then is the answer. Here's another way to request division. It's rather direct, but it uses words. What is 30 divided by 5? You see, and I can write it like this. I can interpret this as 30 divided by 5 this way, or as 30 divided by 5 this way. You see, so either one of those is fine. In any event, we get 6 as the result. Find the quotient of negative 81 and 3. Now, the word quotient is the answer in a division problem. So a division problem is implied when the word quotient is used. And when it says the quotient of one thing and another, it means this thing divided by that thing. You see, so if we're thinking of this in fractional form, the quotient of one thing and another puts one thing in the numerator and the other in the denominator. It's that idea. So this is negative 81 divided by 3 as the interpretation of this. Signs are different, so we get a negative answer. 81 divided by 3, 27. So negative 27 is the quotient of negative 81 and 3. There are a couple of special cases I want to mention here. Look at all three of these fractions at the same time. Now notice there's a 10 and a 5 in numerator and denominator of all three of these. It's just the position of this negative sign or this minus sign that is changing from problem to problem. Now I want you to notice that the minus sign can appear in the numerator, it can appear in the denominator, it can appear as the sign of the overall fraction. And it turns out that the result will be exactly the same for all of these. That is, here the signs are different, so we get a negative result. 10 divided by 5 is 2, so negative 2. Here the signs are different, we get a negative result. 10 divided by 5 is 2. And here this can be thought of as the negative of 10 divided by 5. 10 divided by 5 is 2, so this is negative 2. Negative 2. We get the same answer in all of these, and the important thing to notice is that this minus sign appears in three different positions in this fraction. And the implication later on in mathematics is this, that if we had a fraction like negative 4/5, you see, negative 4/5 has the same value as, or can be replaced with, negative 4 over 5, or 4 over negative 5. These all mean exactly the same thing. And there are certain situations in math where we would want to see this and write that for a certain purpose, and where we might see this and write that, or we might see this and write that. You see, so it's important to know that these are interchangeable. Now, 0 in a numerator or denominator is another special case. And to decide what this is, or how to resolve this, or how to perform this division, we might think of this as a long division problem. You see, this is 0 divided by 5. What is the result of 0 divided by 5? Well, we can tell by interpreting this as a long division problem. Let me come out to the side and do that. All right, we know this means 0 divided by 5. So that's 5 into 0. And this long division problem is a request for a number that we put in this position, which can be multiplied times 5 to get 0. What times 5 is 0? Oh, 0 times 5 is 0. So we meet the request by using 0 as the quotient. So 0 times 5 is 0. The answer then in the division problem is 0. So 0 divided by 5 is 0. Now, what about 5 divided by 0? 5 divided by 0. Different problem than this one. Let's slide over and work that. 5 divided by 0, that means 0 into 5. This is a request for a number, which we put here, and multiply times 0 to give 5. Is there any number which we can multiply times 0 to give 5? No! We can't find such a number. So this is not a possibility. We can't define this then. We have no definition for this division. And we say then that we have no integer that makes this, that we can resolve this with, or we simply say that this situation is undefined. Now, when you get confused about these two, that is, 0 in a numerator becomes 0, makes the fraction 0. 0 in a denominator makes the situation undefined. But it's easily forgotten. But if you forget, you can always go to the long division form to be able to answer the request. Okay. Consider this word problem. It says, the combined scores of 5 golfers was negative 10. Negative 10. Now, negative 10 is 10 under par, if you're familiar with golf. And only professional golfers, presumably, would be shooting scores that would be this great. But the combined scores of 5 golfers was negative 10. What was the average score of the 5 golfers? Well, remember, average, we talked about there being 3 different words associated with average: mean, median, and mode. Usually, though, when a problem is requesting average like this, it implies the mean. So we're going to find the mean. Now, when you find the mean, remember, you add up all the scores. They've already been added for us here. You add up all the scores and divide by the number of scores. There are 5 golfers, so we're dividing by 5. So it implies that we're taking the negative 10, the combined scores of all the golfers, and dividing by the number of golfers in order to get their average score. So negative 10 divided by 5 is negative 2. Negative 2 is their average score. Here's another one involving an average. Low temperatures for 1 week are 4 degrees, negative 5 degrees, 8 degrees, and so on through the rest of the week. Find the average daily low temperature for the week. Well, the average temperature is found by adding all the temperature numbers and dividing by the number of numbers we have. We would have 7 of them for the whole week. But let's see, we have to add them. So we're adding 4 and negative 5 and 8 and negative 1 and negative 12. Gee, I can write it like this. I could say 4 plus negative 5 plus 8. I'm going to put them all in parentheses here just to be consistent, plus negative 1 plus negative 12 plus negative 14, and I'm about to run out of room, and I have 1 more for negative 8. All right, so I'm adding all of these. Now, I could write them, as you know, without the plus signs. I could just go through and write them without the plus signs, and it would mean the same thing. But bringing them all together means, well, let's see. I'm going to look at these and think, well, it's easy for me to bring together the positive ones together with one another and the negative ones together with one another. And I'll do that. I'll kind of separate my thinking that way. 4 and 8, gee, that's 12. And then I'm going to bring together the negative ones, negative 12, negative 5, negative 1, negative 12, negative 14, negative 8. Let's bring all of those together. You know that when bringing together a whole bunch of negative values, we just add the digits and attach the common sign. The sign is negative. So we would have, let's see, 5 and 1, 6 and 12, 18, and 14, 18 and 14. Oh, gee, it's getting too complicated for me. You see, if it gets too complicated and you can't quite do it in your head, then just start jotting some things down. We're adding the digits of 5. Now, I'm just looking at the negatives now. 5, 1, 12, 14, and 8. You see, you can just put them down like this. On the side somewhere, 5 and 1, 6 and 2, 8 and 4, 12, and 8, 20. I'm carrying 2. You see, and then 2 and 1 is 3 and 1 is 4. So this is 40. So negative 40 is the collection of all of those negatives. And now I've got 12 with negative 40. Oh, that turns out to be, and you know, if you have trouble with this subtraction, you're really taking 12 from 40, you see, and you get 28. But if you have trouble, go out to the side and work it. But it turns out to be 28 for the digits involved, and now you attach the sign of the larger of the 2 digits. So larger is 40 and it's minus. So minus 28. Now, that's just the sum of all of these temperatures. But we want the average. Now, the average means that we divide by the number of items that we have, which is 7. So we're calculating negative 28 divided by 7. And signs are different. We get a negative result. 28 divided by 7 is 4. So negative 4 degrees then would be the average daily low temperature for that week.